In this video, I will consider one function and I will simplify this using QM method, that is Quine-McCluskey method. Use Quine-McCluskey method and obtain simplified expression. So it is 4 variable function. It consists of min terms as well as don't care conditions. Now we'll see how to simplify this using QM method. So first I will represent these min terms in binary form. So the min term 7 is represented as 0, 1, 1, 1. So let me consider this is a variable, this is b, this is c, and this is d. So a is with respect to MSB and d is with respect to LSB. Similarly, the min term m9 can be represented as 1, 0, 0, 1. Similarly, 12 is represented as 1, 1, 0, 0. 13 is represented as 1, 1, 0, 1. 14, 1, 1, 1, 0. 15, 1, 1, 1, 1. And the don't care condition, that is 4, 0, 1, 0, 0. And 11 is represented as 1, 0, 1, 1. Now I will represent these binary numbers into different groups depending on the number of ones present in the binary number. That is my first step. Consider the first group as group 1. Here I will consider the numbers which are having only single 1. So here we can see that this number is having single 1. So I will represent it, that is min term is 4. It is represented as 0, 1, 0, 0. So here in this group we have only one number which is having single 1. Now put one horizontal line here. Now I will call the group 2. Now I will consider the numbers which are having two binary ones. So here we can see that in M9 we have two binary ones, that is 9, min term is 9, that is 1, 0, 0, 1. In 12 we have two ones, so I can write 12, 1, 1, 0, 0. So thus we have only two numbers which are having two number of ones. Put one horizontal line again. Now I will consider group 3. So in group 3 I will consider the binary numbers which are having 3 number of ones. So here M7 is having 3 number of ones. So the min term is 7. It is 0, 1, 1, 1. After that we have 13. We have 11 where we have 3 ones. That is 11, 1, 0, 1, 1. Similarly we have 13. That is 1, 1, 0, 1. Then we have 14 which is having 3 ones, 1, 1, 1, 0. So that's over. Now we'll consider group 4. So in group 4 I will consider the numbers which are having 4 ones. 15, that is 15 which is having 4 ones. We'll call this as column 1. So in Quine-McCluskey method, now we are supposed to compare the adjacent groups. Group 1 is compared with group 2, group 2 is compared with group 3, group 3 is compared with group 4. So while comparing group 1 to group 2, there should be a single bit difference between one number to another number. Likewise, we are supposed to compare all the numbers from group 1 with all the numbers of group 2. Likewise, we are supposed to compare all the numbers of group 2 with all the numbers of group 3 and so on. Now let me compare group 1 with group 2. That will be my second step. That is, let me write column 2. So in 4, we can see that if I compare 4 with 9, it is differ by 3 bits. So we'll ignore this. Now I will compare 4 and 12. If I compare 4 and 12, 4 is 0 1 0 0. Here we have 1 1 0 0. So here this bit and this bit is different by 1 bit. Rest all bits are same. So I can consider the min term 4 and 12. Those I will write in next column. So I will consider 4 and 12. It is different in MSB bit. That is the number where it is different, that will be represented as dash. The remaining numbers will be represented as it is. That is 1 0 0. So now once the comparison is done, we supposed to put the check mark which indicates in those numbers there is a difference by 1 bits. So here no more possible comparison between group 1 and group 2. Now I will compare group 2 with group 3. So here if I compare 9 with 7, it is not differ by single bit. So I will ignore this. If I compare 9 and 11, that is between 9 and 11. So in 9 we have 1 0 0 1. Here we have 1 0 1 1. So here this bit and this bit, that is a different by single bit. So I will represent these two in next column, that is 9 and 11. The first two bit I will write as it is 1 0. It is different by this bit, so put the dash for that. Next number is again, next bit is again represented as it is. So as we have compared these two, we supposed to put check mark for 9 and 11. So let me compare 9 with 13. 9 and 13. So here we have 1001. Let me remove this. 1001. Here we have 1101. So here this bit and this bit, there is a different. Rest all are same. So I can represent 9 and 13 here. That is 9 and 13 min terms. The first bit is 1. It is different in second bit, that will be represented as dash. Next bit is 0. Next bit is 1. Thus we compared 9 and 13. Put check mark to 13. 9 already there is a check mark. We no need to put it again. So if I compare 9 with 14, there is more than 1 bit different. So I will ignore that. Similarly, now I will compare the number 12 with all these bits or all these numbers. So when I compare 12 with 7, there is more than 1 bit different. So I will ignore that. Then 12 and 1, there is more than 1 bit. I will ignore that. If we compare 12 and 13, there is a 1 bit of difference. 1101. Here we have 1101 01. So the LSB bit is different. So I can write 12 and 13. That is 12, 13, 1, 1, 0. It is different in LSB. So it is dash. So already there is a check mark for 12 and 13. No need to put it again. Now I will compare 12 with 14. So again it is different by 1 bit. So this bit is different. So I can represent it as 12, 14. It is 1, 1 dash 0. So anyhow already there is a check mark for 12. Now I will put check mark for 14. Line. So thus the comparison between group 2 and group 3 is over. Now we'll put one horizontal line just to indicate the completion of comparison. Now I will compare the group 3 numbers with group 4. So now let me compare 7 and 15. It is different by 1 bit, that is 0. Here it is 1, that is MSB bit. So I can write here 7, 15. So it is the dash 1, 1, 1. So I will put check mark for 7 as well as 15. So I can compare now 11 with 15. Again it is different by 1 bit, that is the second bit. This is the different bit. So I will write it as 11, 15, 1 dash 1, 1. So already there is a check mark. We no need to put it again. So now compare 13 with 15. So there is a difference in this bit. So I can write 13, 15. That is 1, 0 dash 1. So already there is a check mark. Now I will compare 14 with 15. that is 14 with 15. Again there is one bit difference, that is LSB bit. I can write it as 111. So now again this process will be continued. Now I will call this as group 1, this as group 2, and this as group 3. Now I will again compare group 1 with group 2 and group 2 with group 3. That I will write in next column. That column I will call it as column 3. Now compare the min terms 412 with each number of group 2, and where there is a single bit different, that number we supposed to write in column 3. So first I will compare the numbers. So in 412 in MSB there is a dash. Now we'll compare this number only with the number which is having dash in MSB. So here we don't find any number that is dash in MSB, so I will ignore that. So we don't find any single bit difference between group 1 and group 2. Now we'll compare group 2 numbers with group 3. Sorry, here it's supposed to be 1 So now let me compare group 2 numbers with group 3 numbers. I will take the first number 911. Here we can see that there is a dash in this bit. So here we can see that there is a dash here. So in third group we can find dash in the same bit here. Now if I compare 911 with 1315, we can see that there is a difference in this bit. So now let me write 911 and 1315 min terms in third column. That is, now I can represent it as 911, it is 13 and 15. So the first bit is 1, second bit is different bit, that is dash. Already there is one more dash, and last bit is 1. So now we supposed to put check mark for 911 and 1315. So similarly now compare 913. So here there is a dash. Now compare the number which is having dash in the same position. So here at 1115 there is a dash. Now I'll compare 913 with 1115. So MSB bit is same. So here there is a difference. Here we have 0 and here it is 1. So it is differ by 1 bit. So let me write 913 and 1115 min terms in column 3. That is 913. Here we have 1115. So it is 1. Next bit is dash, dash, next bit is 1. So let me put check mark for this 913 and so now compare 1213. Here LSB there is a dash. So in group 3 we can find here there is a dash. Now I'll compare 1213 with 1415. So first bit is same, MSB is same, next bit is same, and here it is differ by third bit. Here it is 0 and here it is 1. Now let me write 1213 and 1415 here. 1213 and 1415. 1415. So the values are 1 1 dash dash 1 1 dash dash. Now let me put check mark for this and for 1415 for this. So now let me compare 1214 with group 3. So here we can find dash. So compare the number in group 3 where having dash in the same position. So here we have dash. So if I now compare 1214 with 1315. So we can write 1 1 dash. So here there is a different bit. Here it is 0 and here it is 1. So I can write 1214 and here it is 1315. 1315. The numbers are 1 1 dash dash. So now let me put check mark for this, and already there is a check mark here. So now the numbers which are not having the check marks, those are known as prime implicants. Let me write the list of prime implicants. That is list of prime implicants. Let me see the column 1. So here we can see that all numbers are having check marks. So we cannot find any prime implicants here. So here we can see that 412, there is no dash. So I can consider 412 as a prime implicant. So as we know, the first bit is with respect to A, second bit is B, C and D. Now let me write this number 412 is nothing but dash 100. It will be represented as, so ignore this dash. So B C bar D bar. I can write it as B C bar D bar. So we have considered this, and in group 2 here we can find all check marks. So for 715 there is no check mark. So this is another prime implicant and its value is B, C, D. B, C and D. So now in column 3 we can see that 9, 11, 13, 15. Here we have 9, 13, 11, 15. These both are having same min terms. So we can strike out 1 and consider only 1. Similarly here 12, 13, 14, 15. Here we have 12, 14, 13, 15. Both are same min terms. We'll strike out 1, we'll ignore 1. So now here we can see that there is no check mark for this. This is another min term and its value is A, D. A and D. So here 12, 13, 14, 15 is another prime implicant. Its value is A, B. That is A and B. Now we'll try to simplify further using prime implicant chart. With the help of prime implicant chart, we can find essential prime implicants as well as prime implicants. So this is the prime implicant chart. So here column wise we supposed to write all the min terms given in the function. The given min terms are 7, 9, so this is the prime implicant chart. So in column wise we supposed to write the given min terms along with the don't care numbers. The given min terms are 7, 9, 12, 13, 14, 15 and we have 4 and 11 are the don't cares. So we found the list of prime implicants, those we supposed to write row wise. That is, the first prime implicant is B, C bar, D bar. We supposed to write here B, C bar, D bar. So now let me write its min terms, that is 4, 12, 4, 12. Similarly, second min term is BCD, which is with respect to 715. BCD min terms are 7, 15. So next min term is AD, which is with respect to 9, 11, 13, 15. AD 9, 11, 13, 15. Similarly, another prime implicant is AB. The min terms are 12, 13, 14, 15. 12, 13, 14, 15. So here the prime implicant B, C bar, D bar covers the min terms 4 and 12. Let me put check mark for all those min terms. So it is 4 is here, put cross mark like this, and 12 is here, put cross mark like this. Similarly for BCD it covers the min term 7 and 15. It is 7 and 15 is here. Here we have AD, which is with respect to 9, 11, 13, 15. 9, 11, 13 and 15. Here we have 12, 13, 14, 15. So now after this, we supposed to identify the columns in which there is only one check cross mark. So in this column we have one cross mark, put a circle like this, and in this column we have one cross mark, put a circle like this. Then here we have one cross mark, put a circle like this, and here we have one cross mark in this column, put a circle like this. In rest all column there is a cross mark more than 1. So here this is the essential prime implicant which is having single cross mark in a column. So this is essential prime implicant. As 4 and 11, though there are a single cross mark in that column, these are don't cares, so we no need to consider this. So this will be essential prime implicant. This is essential prime implicant, and as well this is essential prime implicant. So now we'll write the function, that is simplified function. F is equal to, first write the essential prime implicants. Here this is the cross mark which is with respect to row BCD plus the another essential prime implicant is AD. So after this BCD will cover the prime implicant 7 and 15. Put check mark for 7 and 15. So it covers two min terms. Next 9, 11, 13, 15, that is another essential prime implicant, will cover the min terms 9, 11, 13, 15, that is 9 is covered, 11, 13 and 15 is already. So now here we can see that the min term 12 and 14 is not yet covered. So we supposed to consider few more prime implicants. Those will cover the 12 and 14. So if we think of 4 and 12, the min term, the prime implicant B C bar D bar, it will cover 12 but not 14. Let me check 7, 15. Let me check 9, 11, 13, 15. If we think of 12, 13, 14, 15, so this prime implicant will cover both 12 as well as 14. So we supposed to consider this prime implicant also in our function, though it is not an essential prime implicant, but we supposed to consider in a function. So we supposed to consider this one, that is A, B. So with this it will cover all the min terms. So we no need to bother about the don't care conditions once all the given min terms are covered. So this is the final expression, final simplified expression, that is for the given function the simplified expression is BCD plus AD plus AB. Even if you verify this using K-map, we will get the same thing. Let me verify this using K-map for understanding purpose. So now let me verify using K-map. Let this is variable AB, this is CD. So the min terms are 7. So write 1 in cell number 7. 9, we have 12, 13, 14, 15, and don't cares are 4 and 11. For don't cares, we supposed to use cross marks 4 and 11. The remaining cells are filled with zeros. So this is the 4 variable K-map. Now let me simplify this by doing the grouping of ones. So here we can do one quad, and the value of this is AB. Now this 1, 1, 1 and with don't care, we can do one quad here. Its value is, with respect to column, the common variable is D. With respect to these two rows, the common variable is A. And here we have one more one. This I can do the pair with this. So value of this is, here the common factor is 1, that is B, and here it is CD, B, C, D. So therefore now I can write function F is equal to, we have AD plus AB plus BCD. So here with Quinn-McCluskey method we got BCD plus AD plus AB. Here BCD plus AB plus AD. Thus we got the same result. Thank you for watching.